The number of possibilities is growing exponentially, doubling every time I flip a coin. There are literally gajillions of universes out there, of which ours is only one. Actually, in fact, I calculated it one day. If you look at the total number of bits there could possibly be in the universe, so let's ask how many quantum coins could have been tossed since the universe began 13.8 billion years ago. A simple calculation tells you that the maximum number is 10 to the 120. There have been 10 to the 120 quantum coin tosses, which means that there are 2 to the 10 to the 120 different possible universes. Well, it's a large number, but it's finite. I just told you what it was. It's not infinite.
The quantum multiverse feels like something straight out of a science fiction story. But for some physicists, it's an inescapable reality.
Whether you like it or not, the fact that we live in a multiverse is the dominant scientific paradigm. Suck it up, if I may say so again.
This magical multiverse tour has taken us to some weird and wonderful places indeed. We've journeyed across an infinite multiverse quilt and dived into a giant inflating sea. And as if that wasn't enough, we've wandered through a thoroughly dizzying quantum maze. So if you were starting to feel like you've fallen down a rabbit hole into Wonderland, it's worth pausing for a moment to ask, which theory is right? And can anyone actually prove it? For its most vociferous critics, the multiverse is unscientific because it can't be tested, even in principle. So without proof, doesn't this make the whole idea of the multiverse simply a waste of time? Well, not necessarily.
Truth goes through 3 stages. First it's ridiculed, then opposed strongly, and finally it becomes self-evident. Perhaps now we are reaching the stage of self-evident. The universe went through the Big Bang. We can think of the pre-Big Bang era as a space which is abstract, is an energy space. And various places on this landscape, on this energy field, can produce different universes. We can think of these waves leaping over the rocks as the wave function of the universe trying to travel through this landscape structure. If I think of the rocks as the energy field and each pocket on these rocks representing an energy valley on the landscape, as the waves come through, many of them will be trapped in different pockets rather than travel any further. Each of these little pockets can be a potential birthplace for a universe similar to ours.
Laura's idea was to represent space a bit like a mountain range of different energies. She thinks that our universe started out as a wave. As it crossed a landscape, some energy got trapped, creating different universes with different properties. It is without doubt a radical notion. But Laura also predicted a series of anomalies, which she believed could actually be observed in our own night sky. And one of these would even reveal how our universe was once entangled with another, through a process called crosstalk.
These universes are not only producing space-time, but they are also separating from one another. Each one of those is taking its own identity. However, traces of that infancy, of that crosstalk between all the surviving universes and the landscape structure, those are imprinted forever in our sky. Because after all, what we look at today in the sky is just a blown-up version, a rescaled version of what once was in our universe when it was in its infancy.
Laura predicted that this crosstalk would leave an imprint on our early universe, a bit like a birthmark, and we could see this as a cold spot in the cosmic microwave background.
The detection of the cold spot was one of the signatures that we predicted by tracing forward the quantum entanglement of our universe with all the other surviving universes. We predicted that there should be a large area in the sky of about 10 degrees, and indeed that's what was observed about 7 months after we made the prediction.
Remarkably, all of Laura's predictions have since been observed, including this cold spot, which she claims is a trace of another universe once entangled with our own. It's a discovery beyond anything she dared hope for.
That felt incredibly good. It was unbelievable. I really got excited and allowed myself for a moment to think that there might be something more to this idea. And when I heard the list of anomalies, I was so elated and happy and couldn't believe my eyes that I allowed myself for a few minutes to jump up and down. I was jumping on the balcony. I wonder.
Have made another important discovery.
Space scientists hail a great advance, claiming the first direct evidence of what happened in the first moments of the universe. An international team of leading space scientists say they found the first direct evidence of how the universe was born.
Scientists had been scanning the sky looking for evidence of gravitational waves. The news that they thought they had found them caused a sensation, because if confirmed, it offered yet more tantalizing clues to the existence of the multiverse.
So this has been a really exciting time to be studying the theory of inflation, because inflation predicts that there would be gravitational waves formed during the inflationary process. These are ripples in space-time. It turns out that those gravitational waves leave a telltale signature in a pattern on the microwave background radiation. And that signature has been searched for a long time because it's a prediction of inflation.
The data in 2014 turned out to be a false alarm. But the theory is solid. The idea is that the violent nature of inflation created gravitational waves. These waves would have warped the fabric of space and produced a particular pattern of ripples in the cosmic microwave background, enabling us to observe them, even today. The hunt is still on for evidence of gravitational waves, but if they're discovered, it would be a huge leap forward for the idea of the multiverse.
Gravitational waves, I think, makes the multiverse more likely in two ways. The first is that the multiverse is a prediction, really, of inflation. And so because this makes inflation more likely, it then makes the multiverse more likely. Second, I would say that the sorts of models, the simple models that people have been thinking about for 30 years that give rise to eternal inflation, are precisely the sort of models that are compatible with these theories.
Scientists are still looking for proof of gravitational waves, but if found, it will be a major step forward in cosmology.
So this really makes me feel excited to be a cosmologist and be alive and working now. This is a spectacular time that we're never going to have in human history again. We've learned what the history of the universe is, and now we're learning sort of where the universe came from. How is it born? Were there other universes born? And we're actually making progress. We're not just talking, we're learning real things, and we've come incredibly far in that quest.
These new ideas have given great support to theories of the multiverse. And to those critics that suggest the idea of the multiverse is a waste of time, well, it's given them something to think about too.